Welcome to our presentations for our theory of combinations assignment 1. I'm Tan Guangzi with my members Amel and Ishan. So let me introduce what we have done. So in this assignments, we done some NFA conversions to DFA. So in this set of strings, our aim is to build a combination of DFA that we can explain all of the strings. Here's my set. Uh, okay, I'm responsible for these strings and come with the regular expressions A union K, union V, and union 3. And it's because each strings have a similar pattern of open bracket and close bracket. And with these regular expressions, I come with this epsilon and FA. So this table and diagram is came from the regular expressions. I have to minimize of the epsilon NF and come with this normal NFA. So this NFA without the epsilon. To convert to the DFA, I identify all the enclosed of all state, and then I list all powers, all possible power set. I added the empty state because we have empty state and closed acceptance state. So I added an empty state, which is we can call it a dash state as A. And after the minimize, I construct these tables, which can help me to complete my DFA. So here is my DFA. Let me do a demonstrations for uh, all the automata I have construct. So here is the epsilon DFA. So I can run it, and it shows the same result with is our expected result. And second one is the NFA. NFA, and we run. So it also show the all the string is accepted and other from this is rejected. Finally is the DFA. Here is my DFA, and we can test it with the multiple runs. It also accepted all the strings and rejected except from the uh, expected string. So here's my explanations on set 1. So I will pass it to my next member, Amil, for set 2.
Hello, I'm Ami. So this is my set 2. So my strings are AK, AK1, AK2, AK3, and AKV. So this is my regular expression. So this essentially is derived of AK, which essentially is the concatenation. So this essentially says that A must be started first and then must be followed immediately by K. And the parentheses essentially group the choices of one or two or three of V together. So it says that AK must come first and either ends with one or two or three of V. So I've taken this regular expression, and put it into epsilon NFA, which has the empty jump. So it starts off in Q0. There's 5 states here. So Q0 transitions to Q1 with an empty jump, and then Q1 to Q2 with input A, Q2 to Q3 with input K, and then finally Q3 into the accept state Q4 with either 3, 2, 1, or V. So this is the NFA transition table. So I also minimize the epsilon NFA to a normal NFA, which I just remove the epsilon here. So same thing, 4 states, transitions from Q0 to Q1 with A, then Q1 to Q2 with K, and then finally Q2 to Q3 with these V1, 2, or 3. So here's the table again. So from NFA to DFA, I identified all the enclosed states of each state that I did in my NFA. And then I listed out all possible power sets, which is 2 power 6, which is 64. But I only listed out the ones that are reachable from the start state, which are these. And similar to my group member previously, I also added the dead state or the dead state. So these are just the empty states. So I added it here, and then we minimized and simplified it, and I changed the start state to B, and then the except state to E. So this is the DFA table, and this is what the DFA looks like. Now I shall continue with my demo of the test data. So I'll start off with my ENFA first. So here's the ENFA. I will run the inputs. As you can see, we get the same results as the one here. So accept, reject, same here. Now the NFA, which if I run it here, I also get the same results as previous. And then finally my DFA, which I will also run and get the same results as shown here. So this shows that these are the 4 accept states and these are the 4 reject states. So that is all from my set. I shall pass it on to my next group member, Tan Yishan.
Hello, sir. My name is Wong Yishan. I'm continue to set 3. Let me share my screen. My string is V1, V2, V3, KVA, KV2, and KV right arrow. On my regular expression, there's a typo on our report, which is missing a one bracket on the front and missing the cross bracket on the end. But here is the NFA construct from the regular expression, which is using the Thompson method. It looks like this. On this state, I create the epsilon NFA transition table, which look like here. On the next step, I transform the epsilon NFA to a non-epsilon NFA. It look like this. It's more complex. And the NFA transition table is on below. That's the value. After that, I starting transform it from NFA to DFA. First step is I identify all the epsilon closer, which is all the value is on here. And next, I found out that there's a 20 state in my diagram, and it's million of possible. So I only choose that the state which is reachable or unreachable state is considered is a dead state. Here is all the value. Then next step, I create a DFA transition table from all the reachable state here to get all the input and the next state. On here, I rename all the state, which is A is equal to Q1 and the representing, and the dead state I representing in a F state. Next is my simplified DFA table, which is the rename after the rename the table and the state with that state is F. The DFA looks like this. So the test data is showing here, and I will demo the test data and make sure the result is as expected. First is our NFA epsilon. I run the input. All the inputs show that V1, V2, V3, KV2, KVA, KV right arrow is accepted. Other than that, is rejected. The next is the epsilon free NFA. The input and the result is also accepted as the previous. And the last one is a minimized DFA state diagram. The input also is V1, V2, V3, KV2, KVA, KV right arrow is accepted. Other than that, is all rejected. That met our expected result. Okay, next is our combination of DFA. We combine all our DFA to NFA by Thompson algorithm again and do the conversion. Here is our combined NFA. The next step, we construct our regular expression, which is following from all the DFA. We combine it using the union. So there's one here, second, and the third set. Here's our epsilon NFA table. Again, there is too much possible power set, so we only reach out all the reachable state and show the state is going on here. And next, we combine all the state we reach above to a DFA table. The next step is we transform the table from the DFA to make sure that all the state irreversible like Q5 to Q17 is actually the value combined from these two rows. And where is this getting is from all the reachable state. So next, we rename our state. The Z is representing the dead state, and all the with star is the accepting state. We name it and construct a new table. The table on here is also very complex, so we simplify our table. We have how we simplify it. We have a final state and OPQR, and we list out all the state that can reach the final state is here, and also we list out all the state that can reach this state, which is ABGJ, and we confirm this state is will need to be maintained, and all other state is constant that it is a dead state. So we construct a new symbol T that is all the accepting state, and S is all the rejecting state. Here is our simplified final DFA table. Here is our final simplified DFA diagram. Next, I will pass to my group member to demo it.
All right, let me do the demonstrations for our final DFA. So in our final DFA, we have two NFA should be construct, which is this one is the epsilon NFA and our final DFA. So on our test case, we actually put every string which is need to be accepted by us and rejected case for others. So here is our epsilon final epsilon NFA, and if you do the multiple run, you can see our string is getting accepted and others from this is getting rejected. For the simplify DFA, we also getting the expected result and rejecting, which is proving this epsilon fit our set of strings. So the final DFA is the automatons for this set of strings. And here come to our conclusions.
So in conclusion, we essentially understood that this assignment demonstrated that constructing these formal languages, we started with the crude character strings that we received, and we made them into regular expressions based on the sets that we were given, and eventually we made them into fully functional and running finite automata. So what we found is that we analyzed the rules of the different set of strings, like my first group member set, where it focused on enclosed elements using the brackets, and my set that included certain prefixes such as AK, and finally my last group members who focus on variable endings that include different numbers and variables. So we also learned that this assignment from this assignment that NFAs were more user friendly in the design at first because of the adaptability of the epsilon transitions. But on the other hand, transforming them into DFAs were also very important to establish a deterministic system where each input has one and only one path. So that is what we concluded from this assignment. That is all from us, Group 9. Thank you very much and have a good day.